Hey guys, welcome back to my channel and I hope you are all doing great. And today onwards we are going to have a series of videos on linked list data structure and I'm going to start from basics to advanced. Basics that means like I'm going to cover why do we need linked list and introduction to linked list followed by the basic operations such as insertion, deletion, traversal of linked list and what is the real time use examples of linked list and followed by that we are going to solve few important problems most frequently asked problems on linked list based on the difficulty levels whether it may be easy or it's medium or it's difficult from different coding platforms such as lead code hacker rank or anything. So I believe strongly that this series is going to help you a lot to clear all your linked list doubts. And the only request is like please do subscribe to my channel and please do encourage me and trust me I'm going to upload more valuable content on my channel. And without further delay, let's get into the today's topic. So we might know already like linked list is a linear data structure, right? So but why do we need linked list? Why do we need linked list? Right? Whenever you're going to learn about any new data structure, it's mandatory to know the what are the advantages and disadvantages of the data structure and why the data structure exists, right? Let's see why do we need linked list. If you carefully observe, so we already have a linear data structure called arrays, right? Arrays. So array stores elements in a linear fashion of similar data types at a contiguous memory location, right? So let's assume this is my array and my array has four blocks here. So the values are like 5, 6, 8, 1. Assume if address of this block is like 100, then this is going to be 102 and this is going to be 104 and this is going to be 108, right? The address can be calculated based upon your base address, that is nothing but this address. Okay, but do we have any limitations or disadvantages on arrays? Yes, we do have, right? The first is arrays are fixed in nature, right? That means you need to know the upper limit of the data even before you insert, right? So, example, you want to insert now five elements. You need to initialize the size for the five elements, right? Then only you can able to insert. Let's example int arr is equals to new int of 5. So without this initialization, okay, you are not supposed to insert your elements, right? So you need to know the size in advance in order to insert the elements, right? So this is the one of the drawback of arrays because like today I have a requirement to store only five elements. That's the reason I initialized. But tomorrow I need to insert 10 elements. Okay, tomorrow I need to insert element, then how I can do that? The only way for me is to create a new array and copy these existing elements into the new array and insert the new elements into that array, right? So that is a drawback. Okay, what is the second drawback? Insertion and deletion are expensive. Insertion or deletion is expensive. Okay, what do you mean by that? Let's assume you have an array something like this. Okay, so the elements are sorted by default. Okay, one, three, four, five. This is a sorted array. Okay, now you have a requirement to insert. Okay, assume the size is four and this is free. Okay, now you have a requirement to insert 2 in this array. Then what you have to do? You know, right? 2 can be inserted here, but this all elements need to be shifted to the right direction, right? So that your end result can look like this: 1, 2, 3, 4, 5. Here you can see, in order to perform an insert operation here, and you are shifting elements of the array, right? So this causes the big O of n time complexity, right? So this is one disadvantage. And same like deletion also. Let's assume you have the same array: 1, 2, 3, 4, and 5. Okay. Now you got a requirement to delete 3. Okay. To delete it. If you delete these 3, so how your your array should look like? Your 4 should shift to the left direction, right? Followed by your 5. And there is the last block of memory which is going to be empty, right? So here, if you carefully observe, deletion also bit expensive. Okay, so this is another disadvantage of using arrays. So what is the one more disadvantage? I can said you, I can tell you, like data loss, right? Let's assume you initialized array with the size of 4. Okay, and you're storing 20, 30, 40, and 50. Okay, now you are asked to insert 60. Okay, then what you can do? You have a size of 4 only, right? So in order to insert this one, you need to delete any value, existing one, right? So you can delete 30 or else 40, 50. Assume I'm deleting 30. If I delete 30, then only I can able to insert 60, right? Then my new array is going to look like 20, 60, 40, 50, right? This is one more disadvantage of using arrays. In order to avoid this, what we can do? So we can create a new array size of 5 and you can insert that. But again, that is also is going to consume memory, right? So this is one more disadvantage. So if you talk like this, so there are few more. Okay, I don't want to stretch out more on this. I hope you understood the basics disadvantages of arrays, right? Now let's see how linked list is going to help us. Let's see how linked list is going to help us. Okay. See, basically linked list is dynamic linear data structure. Dynamic linear data structure. Okay, where data is going to store in a linear fashion. Okay, and in linked list, data will be stored in the form of nodes. Okay, in the form of nodes, and a node can contain two properties. One is data, and other one is pointer. One is data, and another one is pointer. This data is actual value, and pointer points to the address of next node. Okay, and how this linked list overcomes the disadvantages of arrays. Let's see. First disadvantages we saw in array is like it's fixed in nature, right? That means your size of array is fixed by default, right? You need to initialize your array even before inserting your elements. But in linked list, that is not the case. Linked list is dynamic in nature. Dynamic in nature. That means it can grow or shrink at runtime. Grow and shrink at runtime. Okay, that means you don't need to have the what I can say size in advance. Okay, before even performing an operations on that. Okay, it can grow and it can shrink based upon how you are inserting or is deleting data. Okay, at runtime. And this is how it overcome the first limitation of array. So what is the second limitation? I said insertion and deletion, right? So insertion and deletion in array is expensive. But if you carefully observe in linked list, insertion can be done at different positions. Okay, you can insert at a beginning. You can insert at a position, at a given position, and you can insert at end. Okay, and if you take, okay, the time complexities are different. Okay, if you want to insert at beginning, it is going to take big of 1. Okay, if you want to insert at a given position, it is going to take big of n because you need to traverse throughout the list. If you want to insert at n, it is going to take big of n. Okay, and here you no need to have that a kind of rework like arranging the elements. Okay, so you can insert here based upon your what I can say requirement, and deletion also same. You can delete at the beginning, delete at beginning, delete at a position, delete at end. So delete at beginning again it is going to take big of 1 time complexity. At a given position it is going to take big of n time complexity, and at end it is going to take big of n time complexity. Okay. Now let's say data loss, the third limitation of array, right? In linked list, you no need to worry about the data loss, okay? Because since this is grow and shrink dynamical in nature, okay, there is no scope for us to lose our data just because we need to insert something new or else we need to delete some existing one. Okay. Of course, if you delete, data will loss, but I'm talking about the insertion. Okay. That also you overcome. But do we have any disadvantages of linked list? Disadvantages. Yes, we do have. Since linked lists are dynamic in nature, okay, you are not supposed to access element randomly. Okay, random access not allowed. Random access not allowed. What I mean by that, so in array you can access something, right? Array of something 2. So it will return you the value of index position 2, right? So this kind of facility you won't get. So if you want to retrieve any node value, you need to traverse complete list, okay, till you find that node. Okay, here it is going to take big of n time complexity. This is one disadvantage. And the second disadvantage is it is going to allocate extra memory for pointers. Extra memory for pointers. As I said, like in linked list, you're going to have two properties, right? One is data and the pointer. So the address where this is an extra, right? In array, you can store only this, and memory is calculated based upon your base address, right? Till the remaining elements. But for linked list, you are going to allocate the some extra memory for this also. So that is also one of the disadvantage. Okay. And these are the advantages and disadvantages. So let's try to understand the some terminologies of linked list. So linked list are different types. Okay. One is singly linked list. Singly linked list means where it is going to have only two attributes in each node. One is data, other one is pointer, and each node connected to the next node in a unique directional. That means only forward direction. and again here, and this is one more node. Okay, if you carefully observe, this is my node 1 and this is my node 2, this is my node 3. And here I would like to highlight one more point. There will be few terminologies like head. Okay, head always points to the your first node. Okay, if your list is empty, then head points to the null. Otherwise, it points to the first node, and your last node pointer references to null. Okay, so this is how your structure. Okay, don't forget to remember this head. Okay, head is not a separate node. Okay, head is something which points to our first node if our list is not empty. If our list is empty, it is going to point to the null. Okay, and your last node pointer references to always null. Okay, this is unit directional and there is only forward direction. Okay, that means you can go only forward. You cannot come backward. This is not allowed. Okay, this is all about single linked list. And we have something called doubly linked list. Okay, so let me zoom in bit. Yeah, great. Doubly linked list means it is going to hold three attributes. Okay, the middle one is a data, and this is previous pointer, and this is next pointer. What I mean by that, as I said, single linked list allowed only forward direction, right? But doubly linked list allows bidirectional flow. Bidirectional. That means both forward and backward are possible. Okay. So how it is going to be is, so if this is a node, okay, this next pointer points to the next node. Okay. Assume this is my another node D PTR PTR. But its previous node points to this node. Okay, that means like each node can point to its previous node and its next node. So I'm going to create one more node. Okay, and here it is going to point. Then what about this? So this is going to point to the null. Okay, because there is no previous node, right? This is only the starting, and head also points to this head. Okay, and this next is going to point to the null because there is no node after this, right? So this is what about the doubly linked list where you are allowed bidirectional. That means you can go forward and you can come backward. Okay, and one more type of linked list is circular linked list. Circular linked list. Circular linked list can be a singly linked list, or it can be doubly linked list. Okay, so now I talk about singly linked list. So if this is my list P and D P and then D P. So if this is my list, so circular linked list is nothing but the last pointer points to the first element, first node I mean to say. Okay, so that it's forming a circular loop. Okay, so this is circular linked list of type singly linked list. Okay, I mean you can call something like singly circular linked list. Okay, circular singly linked list, the naming is your wish. Okay, so same applies to the doubly linked list. So if you have a doubly linked list something like this, and if this is the case, so this is pointer previous, this is data, this is next, this is P, this is D, this is N. This is P, this is D, this is N, and in, we know in internal it will connect something like this, both forward and direction, and its next is going to connect to the first node. Okay, you are getting my point? So its previous is going to connect to the this one, this node, last node. Okay, so that means it's forming a circular loop, right? So this is all about doubly circular linked list. Now let's see what are the real-time examples of linked list. Real-time examples. Okay, and so far we are trying to understand this data structure, right? But it could be better if we know where we can use this data structure in our day-to-day life, right? I can tell one is train coaches, right? Train coaches. So assume this is one coach. Sorry, I'm bad at drawing since childhood. So this is connecting to other coach. Okay. And again, this is connecting to other coach. And if you see in real time also, the trains are connected using a link, right, of an iron, I believe. Okay. So again, this is the last coach. Okay. This is the, assume this is the starting one. Okay. The special one. Okay. So you can see where each coach is connecting to other and where each coach is connecting to other. And you can treat something like this. So the coach is nothing but data and this link is nothing but pointer which connects to the next coach. Okay. So this is one real-time example I can tell you. And do we have any such examples for a better understanding? Yes, we do have. Okay. What is the second real-time example? So I hope you people know music player a lot, right? So without this music player, so I believe most of the people don't work, right? That means like we addict to the music. Like if you carefully observe here, the music player looks like this, right? Okay. This is a sample diagram. This is a pause or start. Okay. This is nothing but previous, right? This is next to nothing but next. What these two will do? When you click on this one, it will go to the previous song in the list, and when you click on the next, it will go to the next song in the list, right? This is live example of doubly linked list. Doubly linked list, right? I hope you are getting the things. Do we have any such useful examples? Yes, I can tell our browser, I mean to say, browser. Let's assume I can show you in real time. Okay, this one. If I go to here, okay, and I search something like Shiva Prasad Gurram dot hash node, okay, and I'm going to one of my article, okay, and if you see here, I am currently at this position, right? So where I opened one of my article, and you can see if I click on this left arrow, what it is doing, it is going to my previous page, okay, and if I click still next, it is going to take me to the home, okay, and if I click on this right direction, then it is taking me to the my home URL, home page, and if I click on right, and you can see it is took me to the again that article page. So this is one of the doubly linked list example, and where you are having this previous and next operations. Okay, browser as I shown, that is one of the example. So this is all about the linked list. Okay, and its different types. So I hope you enjoyed this video, and please do subscribe. And from next video, we are going to perform the basic operations on linked list such as insertion, deletion, and traversal. And followed by that, we are going to start our exact problem solving where we are going to solve a few important, most frequently asked problems on linked list. And I hope you are liking this content, this series. Please do subscribe, and thanks a lot. Bye.